So this is the second question. This whole network. Okay. In solving this, okay, since these two are in series and these two are also in series, let's make this as CT2. This is CT1. Then these two are in parallel, CT3. Okay, so how do we determine CT1? Since these two are in series, this implies that CT1, they are in series, all in series. They have the same capacitance. So of course CT1 will be equal to CT2. Okay, so how do we determine CT1 and CT2 respectively? It is C1 times C2 on C1 plus C2 since they are in series. Okay, so CT1, CT2 will be equal to, what are their values? C1 is 5, C2 is C1 is 5, C2 is 10. Over 15. Of course, 5 plus 10. So we have this as 50 on 15, which is equal to 10 on 3 for CT1 and CT2 respectively. Now let's look for CT3. CT3, these two are in parallel. These two are in parallel, so their total capacitance will be C1, C2 plus another C2, so NC2. So 2 times 10 microfarad, giving us 20 microfarad. Okay, now this is what it looks like. Here's CT3, CT1, CT2, this is C3, this is the point A. So that's what it looks now. Okay, that's what it looks now. So 1, 2, 3 are in parallel. So let's call their total capacitance CT4. This is once they are in parallel, their combined distance is going to be addition of all of them. So we have CT1 equal to 10 on 3, C3 is equal to 2 plus the same 10 on 3. So we have 2 of this, okay, 20 on 3 plus 2. So this is equal to 26 on 3 as CT4. Don't forget microfarad. Okay, so basically this is what we have. Let me adjust the screen to redraw something. This is CT4. This is the point A. Okay. This is CT3. This is the point B. What it means is that CT4, which is this, if total of this is in series with this. And when capacitors are in series, their total capacitance is the addition of all of them. We apply the product of this on the summation of that. Sorry. So let's CT5. CT5. 5, which is the application of the series to this. So we have CT4 times CT5 on CT4 plus CT5. I'm on 3 rather. And what is CT4? CT4 is 26 on 3. So 26 on 3 times CT3 is 20. All divided by 26 on 3 plus 20. Plus 20. So at the numerator we have what is 26 times 20? 26 times 20 giving us 520. 500. So the numerator we have 520 on 3, and then we have the denominator as 86 on 3. So in all, CT5 is equal to 520 on 3 times 3 on 86, giving us 520 divided by 86. So this is what is 520 divided by 86? So we have 6.07. 6.047. 6.047 microfarad. This is the total capacitance between points A and B. Alright, so this is the total capacitance between the 2 points A and B. So when you are solving this, you take your time gradually, systematic approach, and you can do it. So now let's reorganize our diagram. What it means is that this is CT1, CT2, CT2. This is not there. This is changed to this. Then CT1. Okay. This is, so we reduce everything given to us as this because we found their total capacitance and all that. So once these are in parallel, it means they have the same voltage drop across them. Okay, so the voltage drop across the parallel plus the voltage drop across the series should be equal to the source voltage. Okay, so we only need to find the charge within the circuit. Okay, so Q, which is the charge within the circuit, will be equal to the total capacitance CT5 times V. And we have CT5. Okay, so 6.047 times 10 to the power minus 6, because it's a microfarad, times 60. Okay, times 60, and this will give us a value of 363 microcoulomb. So this is a charge Q. Now when this charge gets to the junction, by Ohm's law, it breaks into this Q3. This is Q2, Q1. Okay, when the charge comes and it breaks up into Q2, Q1, and then upon returning will pass through this. So charge Q comes into this. So if we are looking for the voltage drop across this, it is the charge over the capacitance. So what's the charge? The charge is this: 362 times 10 to the power negative 6 divided by the capacitance, which is CT3. What did we get for CT3? 20. So 20 microfarad. So here we have 362 divided by 20, and that gives us 18.10. So 18.10 volts, meaning the voltage drop across this (18.1) is a voltage drop across this. If the voltage drop across this is 18.10, then the voltage drop across the parallel, V parallel, must be equal to 60 minus 18.10. Okay, this should be 60 minus my answer is 41.9. So V across the parallel is 41.9 volts, approximately 49.1 volts. Therefore, when we are looking for the charge on the third plate, since all of them are connected in parallel, they have the same charge across them. They have the same voltage across them. So 41.9 divided by 41.9 divided by the capacitance C3. So we have 41.9 divided by C3. And what is C3? C3 was given to us as a, let me check for the value of C3. Sorry, the charge will not be divided by. Okay, so it's C times V. So C3 is the value of C3 is 2 microfarad. So 2 times 10 to the power minus 6 times 41.9. Okay. So times 2. This is giving us 83 83.4 83.4 micro coulomb as a charge within KO3. So therefore the charge on plate C3 is 83.4 micro coulomb. Okay, so this is the value of the charge on the capacitance 3. Alright, so simple. So please, when you are given such a problem, just take your time, systematic approach, go through it systematically, and in fact you can handle it at ease. Okay, if you want more questions, please send me a message on things like this. Send me your WhatsApp number as well. I'll give you challenging questions on something like this so that you'll be trying your hands at them. Thank you so much, and thank you for your time. Bye bye.